Hello friends, welcome back for another beautiful project. The title is Credit Card Approval. So here I have developed an unsupervised machine learning model that will take the applicants' features and categorize them into two categories, whether they can get the credit card or not. These are the two categories in which the model will categorize to the applicants. So moving on to importing the libraries. I have imported the libraries like pandas, numpy, matplotlib, seaborn. Pandas for data manipulation, numpy for numerical calculation, matplotlib and seaborn for data visualization. So let's execute this cell. So it is taking some time as the kernel is restarted. It is done. After that, I am importing joblib to save and serialize the model and importing warnings to filter out the casual warnings. So running these two cells. Yes, these two cells are successful. Filter warnings method will filter out all the casual warnings shown in the notebook. Moving on, I have downloaded a CSV file from the Kaggle platform. You can also get the same CSV file from the Kaggle platform, or you can find it in my GitHub repository. I am going to give the repository URL in my description section. So moving on, using the pandas function read CSV, I am reading the CSV file and creating a data frame and assigning that to a variable applicants under df. Using the head function of the pandas and applying it to the data frame to see the first three rows of the data frame. So let's execute this cell. So these are the columns we have in our data frame, and moving on, I am removing the save step because I have written it twice. Okay, it's done. Now moving on, before creating a model, we should carefully see the dataset properties. Properties means nothing but shape of the data frame, columns of the data frame, and information about the data frame. So let's see the shape of the data frame. So the data frame has 4,38,557 rows, 18 columns. What are the columns available in the data frame? So these are the columns we have in our data frame, and let's see what are the numerical columns in the data frame. Let's see what are the categorical columns present in our data frame. So these are the columns we have in our data frame, and these are numerical columns we have in our data frame, and these are categorical columns we have in our data frame. So after all, let's move on to the information of the data frame. So in total we have 4,38,557 entries, that is the total number of rows, and the index starts from 0 to 4,38,556, and in total we have 18 columns, and these are the column names we have, and non null count of the values present in the columns are given in the second column, and the data types are given in the third column. So in the second last line we have float 64 of 2, that means we have 2 columns of float 64 data type, and then 8 columns of int 64 data type, and 8 columns of categorical data type. Moving on, let's see what are the statistics of the data frame. So using the describe method we can see the quantiles of the numerical columns. So executing it, so quantiles are nothing but minimum, maximum, 75th value, 50th value, and 25th value, and with that we are also getting standard deviation, mean, and total number of values present in that column. These are the numerical columns whose values are shown here. So moving on, we have to go for correlation. So we have a beautiful core function in pandas which is applied to the data frame variable using the argument numeric only equal to true. Whenever we set the argument numeric only equal to true, the core method will only take out the numerical columns and performs the correlation among those columns. So let's execute it. This is the correlation table of numerical columns in the data frame. So observe it carefully. Flag mobile is correlated none with all other columns. You should notice it. And we have negative values in dash birth and dash employed column 2. After that I am going for data cleaning. So the first step I am doing is renaming the column names. So to rename the column names we have a rename method in our pandas. So using the rename method and applying it to the data frame variable, I am renaming the column names, and replacing the modified data frame with the original by setting the argument in place equal to true. So let's run it. Yeah, successful. After that I am checking whether our data frame has duplicate values or not. We have a pandas function duplicated which returns true if any duplicates are available in our data frame, and returns false if no duplicates are available. When we apply dot sum to it, the number of duplicates rows present in our data frame will be returned. So let's run it. So we have 0 duplicate rows. After that let's find out if any null is present in our data frame or not. So in pandas we have is null method which will return true if null is present and returns false if null is not present. So applying dot sum to it, returns the number of nulls present in the applying dot sum to it returns the total number of nulls present in each column of the data frame. So let's run this. Except occupation type column, we have 0 nulls in all other columns, and in occupation type column we have 1,34,203 rows with null values. Moving on, I am going for unique values. So when we apply unique method to a column, it will gives unique elements of the column. So applying unique method to all the columns in a series of cells. So let's execute all the cells and see what are the unique elements present in each cell. So we have M and F in gender, Y and N in car owned, Y and N in realty owned, working, commercial associate, pensioner, state servant, student in income type, higher education, secondary or secondary special, incomplete higher, lower secondary, academic degree in education, civil marriage, married, single or not married, separated, widow in family status, rented apartment, house or apartment, municipal apartment with parents, co-op apartment, office apartment in house type, 1 in have mobile, 0 and 1 in have email, 0 and 1 in have phone, 1 and 0 in mobile working, none, security staff, sales staff, accountants, laborers, managers, drivers, core staff, high skill tech staff, cleaning staff, private service staff, cooking staff, low skill laborers, medicine staff, secretaries, waiters or barman staff, HR staff, realty agents and IT staffs in occupation type, and finally 1 2 3 4 5 6 7 8 9 11 14 15 20 in family members. So as a common says, the number of days won't be a negative value, so we are converting the negative value to the positive value using the ABS method of NumPy. Let's execute these two cells. Okay, successfully we have converted negative values to positive values. Now I am dropping 3 columns because these columns are not useful for model building. Those columns are have mobile, ID, family status. I am going to drop have mobile column because it has only one value, that is 1. So if it doesn't have more than one value, then it is useless for model training. That's why I am removing this column. The second column is ID. You should always remember that you should never use ID for training a model. And I am removing family status because see here, in family status we have civil marriage, married, single or not married, separated, widow. These values won't matter when we apply for a credit card. I hope you are understanding. These values won't matter a lot when we apply for a credit card. That's why I am removing this column. So to remove or to drop columns, we have a method drop in pandas which will drops the specified columns, and I am repeating again, whenever you see in place equal to true, that means the modified version of the data frame will be saved to the original data frame variable, and whenever you see head of 3 or 5 or anything, any number, then it means we are visualizing or we are showing the data frame table. So let's run this and see the first 3 rows. So I have removed successfully the 3 columns. Then moving on, let's check what are the columns available after removing those 3 columns. So gender, car owned, realty owned, children's, income, income type, education, house type, days on earth, employed days, mobile working, have phone, have email, occupation type, and finally family members. We can follow 2 methods to handle missing values in any column. Either we can drop that rows where values are missing, or we can fill the values. So if we drop the rows, then we may lose the data of other columns. So better choice is not to drop the rows. That's what I have done here. I am not dropping the columns, rather I am randomly filling the null values. So let's see what I have done. So at first I am finding out the unique elements present in the occupation type. So to find out the unique elements present in the occupation type, I am using the drop in a method of pandas to drop only null values, then finding the unique elements using a unique method and saving that in occupation variable. After that, using the choice method of random module of np library or numpy library, I am finding out one random value of the list of unique elements in the occupation type column and passing that value to the fill na method, a method in pandas library which fills the null values with the specified value. So taking out a random value from the occupations and giving it to the fill na method, and fill na is replacing with the null value, and then I am again saving the modified column to the original column name. Let's run this cell. Okay, we have successfully filled out all the nulls. Let's check if any nulls are present or not in each column. So you can see we have 0 null in each column. Let's see first 3 rows. So in occupation type we were having nan or null values. Now we don't have null value. In place of the null values we have course tab or some other values, because it is randomly selected by the choice method of numpy. So moving on, The next step is EDA, that is exploratory data analysis. So in EDA we will visualize the data columns and find out the insights from it. So under that, this is here I am finding out the minimum and maximum values of employed days column. Let's run this cell. Yeah, there are 12 days. Someone is worked only 12 days and someone worked 3,65,243 days. So moving on. So I am plotting the categorical columns using the matplotlib and seaborn library. So let's see what I am doing in the first cell. In the first line of this cell, I am selecting the categorical columns and saving it in the variable columns. Then I am building 8 subplots with total figure size 20, 10 and giving a horizontal space between each is 0.3 and a vertical space between each is 0.3. Then initializing k equal to 1, then running a loop among the columns. After that, selecting each subplot, and inside that subplot I am going for a count plot using the seaborn library. So count plot will take minimum 2 arguments. One is x, another is data. So in x I am giving the column name and in data I am passing the data frame. After that I am giving a title to the plot, then rotating the x ticks to 90 degree, then incrementing the k value. After that showing the plot. So let's run this. Yes, the plot came. So you see all the x ticks are rotated to 90 degree and these are all count plots. So you should carefully observe the plots before building a model. So moving on, in next cell again I am creating 8 subplots with 20 width and 10 height and 0.3 space between each plot. Initializing k equal to 1, running a for loop and creating a column dictionary. The column dictionary is saved in calldict. The column dictionary is used to plot a pie chart. That is the purpose of creating column dictionary. So again then I am selecting a subplot, then putting the pie chart inside the subplot. So pie function is available in pieplot module of matplotlib. It takes at least one argument, that is x. So here I am providing the values of the column dictionary and levels are the keys of column dictionary and setting auto PCT to percentile 1.1 f percentile to calculate the percentage of each element in the column and setting the start angle to 90 to start the wedge from 90 degree. then giving a title to it and incrementing the k value. After that, showing the plot. Let's run it. So yeah, each pie chart started from 90 degree and it has some percentage value inside the wedge and some levels M and F. You should carefully observe the plots that you are plotting before building the model. I am moving on. In the next cell, again I am creating 6 subplots. So 2 comma 3 inside the subplots function means 2 is for number of rows, 3 is for number of columns. That's why I am saying 6 subplots with 15 and 10 figure size and giving 0.3 units of space between each in horizontally and vertically, then initializing k equal to 1 and running a for loop from second column to the last. Then selecting a subplot, and inside the subplot I am plotting a bar plot. A bar plot is a method of Seaborn library which takes minimum 3 arguments. Those are x, y and data. So in x I have provided the gender column name, and in y income column name, and in data I have provided the data frame and setting hue equal to I is the column name. Then after I am giving a title, then incrementing the k value and at last showing the plot. Yeah, it came. So as we have applied hue, that's why these 2 bars appeared in male section and 2 bars appeared in female section. And this is the income level and this is the gender level. So always remember, you should carefully need to observe the plots before you are building a model. Moving on. So after plotting the categorical columns, let's plot the numerical columns. So in this cell, at first I am selecting the numerical columns and saving it in the columns variable, then creating each subplots with figure size 20 and 10 and giving 0.3 units of space horizontally and vertically, then initializing k. After that, running a for loop from the first column to the last and selecting a subplot, then plotting a histoplot or histogram inside the subplot. And histoplot is a method in Seaborn which plots histogram, and it takes minimum 2 parameters, x and data. In x I have provided column name and in data I have provided the data frame. I have also given an argument KDE equal to true to have kernel density graph in the histogram. After that, I am giving the title, then incrementing the k value, then showing the plot. So let's wait a while, we will find the beautiful histograms. It is taking some time, wait a while. Yeah, we got. So these are the kernel density line. After that I am moving forward and I am plotting a box plot for all the numerical columns, and again I am doing the same and replacing the hist plot method with box plot and remove the KDE equal to true argument from the method. So to plot box plots, we have box plot method in Seaborn library, and that library is used by me here. Let's run this cell. So box plots are used to see outliers present in the column. So these dark black diamond shaped points are the outliers which are present in the column. So these are the outliers of children column, these are the outliers of income column. Similarly, these are the outliers of this column, and this is the outlier of this column, and these are the outliers of this column. So moving forward, I am going for violin plot. Main purpose of using violin plot is to see in which section the maximum points are lying. So I am doing the same, and I am repeating the code and just changing the method name and providing the same arguments to the method. Let's run it. Yeah, we got violin plot. I hope you are understanding the violin plot. So violin plots are used to see in which section maximum points are lying. That's the main purpose to use violin plots. After that, I am moving forward for data pre-processing. In data pre-processing, I am building a column transformer. The compose module of scikit-learn library have a class named column transformer. This class is used to transform each column simultaneously. As we have both numerical and categorical columns, so we need to do different pre-processing steps to each column. So different pre-processing steps need to be performed for each column, and those pre-processing steps are min max scaling, standard scaling, one hot encoding, and ordinal encoding. So to perform these pre-processing steps, we have methods like min max scaler, standard scaler, one hot encoder, and ordinal encoder in the pre-processing module of scikit-learn library. After that, I have created two variables, children count and fam members. So in children counts, I am saving the unique elements present in children's column in sorted order, and in fam members, again I am saving the unique elements of the family members column in descending order. So I am creating a CT variable for column transformer. The column transformer takes three arguments. One is transformer, a list of tuples, and a reminder argument, and sparse threshold argument. So reminder argument takes two values. One is pass through, another is drop. Pass through is used if you don't want to drop those columns which do not require pre-processing steps, and drop is another value passed to the reminder argument if you want to drop the columns which do not require pre-processing steps. So parse threshold will take an integer value. If you set it equal to 0, then sparse output won't be created, and if you provide some value, then sparse output will be created. So transformers argument takes a list of tuples. In each tuple we have to provide 3 values. The first one is name of the preprocessing unit. The second one is preprocessing object, or the method or the function that we use for preprocessing, and the third one is the list of columns to which we will apply the preprocessing unit specified inside the tuple. So mean max scaler, standard scaler, ordinal encoder, one hot encoder is used, and don't worry about ordinal encoder. Ordinal encoder takes one argument categories. If you want to encode as per your wish, then you should provide categories argument in the ordinal encoder, and if you won't provide it, the ordinal encoder will automatically encode the list of columns that you provide to it. After that, in one hot encoder method, I have given 3 arguments: sparse output equal to false, drop equal to first, handle or none equal to ignore. So if we set it true, sparse output will be generated, and if it is false, sparse output won't be generated. And drop equal to first. To drop the first column of the encoded columns, I have used drop equal to first, and the third argument is handle unknown equal to ignore. To ignore the unknown data that is passed to the one hot encoder, I have used handle unknown equal to ignore. After that, I am calling CT variable to see the column transformer. So let's run this cell. As this is not fitted, so the color of the column transformer is orange. If the column transformer is fitted, then the color will be changed to blue. After creating a column transformer, the next step and the last step is to develop the model. So model development is the last step in model building, and model evaluation is the sub step of model development. So don't think that I am saying model development is the last step. I am using KMeans method of cluster module in the scikit-learn library. The KMeans method applies KMeans algorithm. KMeans algorithm is used to cluster the data points based on the distance between the data points. So pipeline class is used to create the pipeline between column transformer and the model. So in pipeline class we have one argument, that is steps. Steps is an argument which takes list of tuple values, and inside the tuple we need to give 2 values. One is the name of the step, another is the estimator which carries out the step, or the object which carries out the step. And the KMeans method takes an argument n clusters, and that is the number of clusters it should form. So I have given the number of clusters to 2 so that the K-means algorithm will cluster the data points into 2 clusters. After that, I am fitting the model with the data frame that I have created. So let's run this. It will. So the color of the pipeline is changed, the color of the column transformer is also changed. It indicates that the model is fitted. After that, I am creating X peer, and the steps should be under the model evaluation. So after that, I am going for model evaluation, and it is not the last step, it is the sub step of model building. XPR is a variable which stores the preprocessed data of the data frame. Let's run this. I am using Davis-Baldwin score for evaluating the model, and the Davis-Baldwin score takes 2 parameters. The first one is the pre-processed data of the data frame, that's why we have created XPR, and the second one is the levels that generated by the model. So Davis-Baldwin score method is available in matrix module of the scikit-learn library. Let's run this cell. We are getting 61% of accuracy. So let's visualize the data. So here in this cell, I am creating 2 plots with a total figure size of 10 and 5, then giving 0.3 units of space in horizontally and vertically, and no need for vertical space because only 2 columns are available and 1 row is available. Then after, I am selecting the first subplot, and inside the subplot I am going for a scatter plot, and the scatter plot method is available in Seaborn library, which takes at least 3 arguments x, y and data. So x and y are names of column and data is the data frame. Then I am giving a title to the subplot. After that I am using the model to predict the levels using the data frame and saving the levels or the predictions in the levels column of the data frame. Then after, I am creating or selecting another subplot and plotting the another scatter plot with the same column names and the data frame, and adding another hue parameter to cluster the data points. After that, I am giving a title to the subplot. Let find. Wait a while. Here you can see the original data points and the predicted data points. After that, let's go for the value counts of the levels generated by our or predicted by our model. So we have 3,32,653 rejected applicants and 1,05,904 selected applicants. And finally, let's save the model using the job leave dump method. and dump method takes two arguments. The first one is the model that we want to save, and the second one is the name of the file. Welcome back for second part of the project credit card approval. So in the second part we are going to develop the user interface through which the user interacts with our model. So let's start it. So at first I have imported the required libraries like Streamlit, Pandas, NumPy and JobLib. So Streamlit is used to create the widgets, Pandas is for data manipulation, NumPy for numerical calculation, and JobLib is to load the model. So the saved model is loaded through a JobLib function, that is load method of the JobLib. So the file name is model.joblib. We have saved under the name model.joblib. That's why we are passing the same name or the same file name to the load method, which is loaded and saved in the variable model. After that, I have created a container that contains title and logo. So inside the container, to create a container, we have st.container. Inside the container, I have created two columns, and the first column is of width 0.5 units while the second column of width 2.5 units, and they don't have borders, and the content starts from the center. That's why vertical alignment argument value is center. So under the first column, that is log col, I have created an image window which shows my logo with width of 100 units, and under the second column I have created the title, and the title is credit card approval with two card icons. After that, I have created a container for about the project section, and inside the container I have created an expander with a label about the project in caps and a rocket emoji, and by default I set expanded argument to true. Inside the expander I have written some text like credit card approval is an unsupervised machine learning project which decides whether an applicant can get a credit card or not. And in the second line I have written KMeans clustering algorithm is used behind the development of this project, and some texts are within double stars which makes the text to appear bold, and some text are between square brackets, and before them some color names, and before color names a colon, which indicates that the text inside the brackets are with the given or specified color, and some emojis or icons are used or to show it beautiful. After that, I have created a container for input section. So there are two kinds of inputs. So for two kinds of inputs I have used two columns, and name of one column is select inp underscore call and the other one is enter inp call. So So select input call carries the inputs which are selected by the users, and enter input call carries the elements which are entered by the user. So their borders are set to true, and select input call is 2 times the enter input call. So under this select input call there are many columns with many input sections. So all those input sections are selected by the users. So I have created a header select inputs for that input section, and under that created 3 columns with gender input, owned car input column, owned real input column. So these are 3 columns, and inside these columns I have created select boxes using the streamlet and given their labels like gender, owned car, owned realty, and followed by the options required for them. So provided with options like male, female, and for car owned yes, no, and for realty owned yes or no. And after that, as we saw, for decorating purpose I have given male and female, but in the real case, in the data frame we have M and F. So I have used an if else case for gender. Similarly I have used an if else case because in data frame we have Y and N rather than yes and no. Same thing is applied to realty owned, and again 3 more columns for income type, education, and house type, and with their respective options, and followed by if elif block. Similarly if elif block for education and if else block for house type. Then to show it beautifully I have changed their names in the option sections, but again rechanged it to the same name as in the data frame. So again I have created 3 more columns for working mobile, have phone, have email, and given same options and have same labels like mobile working, have phone, have email with their own options, and as the data frame contains different values than the options I have provided, so I have changed it to the same value as in the data frame in all the columns. So after that I have created 3 more columns. 2 of them are non-empty columns and 1 is empty column which is not used. For to show it more beautiful I have created 1 more column, because to have the same size select boxes in the area or in the input section or select input section. So after that again I have created the select box occupation type with these options and created if else block to match the value in data frame with the value in this app.py file or the options that shown to the users. And similarly for family members I have created options and created or changed the data type of the family members to float 64. Remember friends, if you have different data types during model building and during model prediction, then there will be some errors which are thrown to us. So before providing the data for inference, we have to change the data type of the data that we provide to the model. So here family members are converted to floating 64 because family members in the during model building is of data type float 64. Similarly, in the enter input column section, the user has to give the input or enter the inputs. So I have created a slider for children's where mean value is 0 and max value is 10, and it is also converted to integer 64 type, and then income where the user has to enter the income of the applicant, and the minimum income should be 26,100 and maximum income should be 67 lakh 50,000. So these are the mean and max value of incomes and days on earth. So next, user has to enter number of days he or she lived on the earth. So minimum number of days is 7,489. This is because all the banks have the predefined age of an applicant. So an applicant must have an age of 20 plus or 21. That's why we have minimum number of days equal to 7,489, and applicants also should not be much older. That's why we have maximum days equal to 25,201. So after that we have employed days, and a user or an applicant, he or she must be employed 12 days, and maximum employed days is 3,65,243 days. After that I have changed the data type of days on earth, income, and employed days into the required data type format, and if those are not selected, then I am by making them default to 0 so that no error should be thrown. I have some suggestions for the new coders who are interested in making these things like me. So point number 1 they have to remember is they have to match the data types of both during model building and during model usage, that is model prediction, and they have to update the libraries which they are using, and libraries should match their required versions with each other, like NumPy and scikit-learn should match their required versions as per mentioned in the official documentation. After that I have created a container for showing the output, and using the pandas data frame method I am creating the data frame and saving it in input df variable and passing it to model.predict and saving the output in the prediction. And as we know, the prediction is either 1 or 0. So if prediction equal to 1, I am showing a success message applicant approved, and if prediction equal to 0, showing applicant rejected. So this case is not required, let's remove it. After that, container for external features of the app. So I have created I have created 5 more links. So 5 more links are for YouTube, Hugging Face page, and my own personal page Medi, and another for repository, and another for connecting with me in the LinkedIn. So these are five links that I am providing with this app. So to run this app, open the terminal by pressing Ctrl and tilt. Open the terminal, and in the terminal go to the directory where your application file is available. So my application file is under credit card approval, credit, it is credit card. So go here. So change the directory. To change the directory, we have cd credit card, credit card approval. Press enter. The directory is changed. Now to run the Streamlit app, we have to write in the terminal like Streamlit run and the file name, that is app.py. Press enter. Yes, so the app is running. Let's zoom it out. So app is building. Yes, we got it. So see here, this is my logo and this is the title of the project or the model, credit card approval, and the here about the project. Inside the about the project, we have credit card approval is an unsupervised machine learning project which decides whether an applicant can get a credit card or not, and KMeans clustering algorithm is used behind the development of this project. So this is an expander, we can close it. So I have closed. If you want to use it, you can expand it. Okay, so after that we have select inputs and enter inputs. These are the inputs we need to provide to the model so that it generates the output whether the user can get credit card or not. So let's check. Let's change it to female, to no. Let's change it to 2 children. Let's change it to accountants. Let's change their income to 500. Sorry, what is the minimum income? 26,100. So 27,000. Let's, the days is 8,000 and employed days is 365 days. So the applicant is approved, and if we change the occupation type, let there be managers, then also the users are approved. If we change them to low skills, applicants are rejected even if they have 27,000 income. And if we change it to IT, applicants are approved, and if we change it to sales, applicants are rejected. So it depends more on their occupation. If they are waiters, applicants are rejected, and if they are managers, applicants are approved. This is what we get. And if they are high skill tech, then what is their status? Yeah, they are approved. If we change them to 6 children, even if they are changed, they are also approved. If mobile is not working, it's okay. If they don't have phone, it is also okay. If they don't have email, it is also okay. It is official, it's okay. If it is municipal, it is also okay. If they have incomplete ED education, it's also okay. If they have lower secondary education, okay. If they are student, it is also okay. If they have 27,000 days, if they are pensioner, it's also okay. If they are commercial associate, okay. State servant, okay. Owned realty, no. And if family members is 14, it's also okay. So it's highly depends on occupation type. It is their core and rejected. The drivers rejected. The managers selected. If they are laborers, rejected. If they are accountants, selected. If they are sales, rejected. If they are security, rejected. If they are cleaning, rejected. Accountant staffs, selected. Labor staffs, rejected. Private service staff, realty agents, selected. This is how the model works. So I hope you find a worthy and useful project, and it helps you a lot. Thank you.